Hello everyone. So now we'll see about the RC series circuit. So last video we have seen that is a combination of resistance and inductance. So now we'll see the combination of resistance and the capacitance. So circuit, you can see in circuit like it's having resistance and it's having the capacitance. So VR is the voltage across the resistance and VC is the voltage across the capacitance. So I is the current flowing through the resistance and the capacitance. So consider an AC circuit with the resistance R and the capacitance C connected in series. And the input is V is equal to Vm sin omega t. So the current is flowing through the voltage across the current is flowing in the circuit, that is I, and the voltage across the resistance is VR and the capacitance is VC. So VR is equal to, the resistance is flowing in phase, so that is VR is equal to IR, which is in phase with current, and VC, the voltage, lags behind the current by 90 degree. So inductance means the voltage is going to lead by 90 degree, and the capacitance means the voltage is going to lags behind the current by 90 degree. So if you see the phasor diagram, again the resistance remains constant, that is nothing but in phase, so it becomes a straight line. But the capacitance, it's going to lags behind the 90 degree. So the graph is going to be down. So if you see the waveform, okay, so there the input remains same, that starts with the origin, V is equal to Vm sin omega t. But the current, I is equal to Im sin omega t plus phi. Okay. So now we'll calculate the expression for the voltage and the angle phi. So V is equal to square root of VR square plus VC square. So we know the input for resistance IR, and for the capacitance it is I of XC. So substitute these two in the above equation. So you'll get V is equal to square root of IR square plus I of XC square. So I, the current, you take it outside like common factor, V is equal to I into square root of R square plus I XC whole square. So these two, that is resistance and capacitance, can be written as impedance. So V is equal to I into Z, where Z is equal to square root of R square plus XC square. Now we'll see the phase angle. Phi is equal to tan inverse of the VC divided by VR. So again substitute the inputs like capacitance, I'll write it as I of XC, and for the resistance I'll write it as a I of R. So phi is equal to tan inverse of I of XC divided by IR. So phi is equal to tan inverse of the current get cancelled, so remaining terms will be XC divided by R. So phi of tan inverse of 1 divided by omega C into R. Okay. Why? Because the XC can be written as 1 divided by omega into C. So this you can this you can understand if you see the previous videos of pure capacitance. So how I can write instead of XC, the 1 divided by omega C. So the final expression is phi is equal to tan inverse of 1 divided by omega C into R. So now we'll calculate the average power. So average power formula, P is equal to V into I cos phi, where V is I into Z, the current remains same, I, and the cos phi is nothing but R divided by Z. So power becomes P is equal to I square into R. So if you see the impedance triangle, okay, so first with respect to VC, if you see where the resistance remains constant, that is in phase, and the capacitance becomes down, the graph is going to plot down because it's going to leads current by 90 degree. The similar phasor diagram will be for the impedance triangle. So XC is going to leads behind the voltage by 90 degree, and the resistance R remains constant, that is in phase.